Good day, everybody. Hello, and thanks a lot for attending. And I'm really, really excited to be part of this amazing community. Basically, this topic actually falls in line with what was presented so far in this fantastic event. And I actually am delighted to attempt to kind of reiterate on what my colleagues mentioned, especially about the awesome world of generative AI. And just in case if you're still, like, for example, scratching your heads on the topic, then this session is actually for you. So without further ado, I would like to present the topic of generative AI. And just one second, let me move this out of the way. Okay, perfect. So generative AI. It's basically a destructive technology, as you've seen in the conference. There's so many things that can be said about the field, about this amazing technology. There are so many applications, so many opportunities that can be discussed, and obviously in one session cannot be covered. And you've seen in the conference that there's so many opportunities and like amazing applications that can actually be implemented using generative AI. So, my name is Mustafa Youldash. I'm an assistant professor from the College of Computer Science and Information Technology from the Department of Computer Engineering. We offer courses that specialize in teaching artificial intelligence to undergraduate students, and hopefully in the future also for postgraduate studies as well. I'm also a certified instructor and trainer and university ambassador by NVIDIA. If in case you haven't heard about the DLI or the Deep Learning Institute, which is part of the NVIDIA, they actually offer specialized tailored workshops that would meet the demands of industry and of course in academia. As an ambassador, of course, we are thrilled to always offer what is new in terms of AI, and of course, its subfields from machine learning, deep learning, data science, and obviously generative AI. So without further ado, the agenda for this topic is going to be kind of lighter compared to the other amazing talks by our colleagues. So I'm going to be basically focusing on three main things, and that is, again, what is generative AI? In case if you're still wondering what this technology would be, and of course, hopefully I'll be able to present a few new important aspects in the field. And obviously the history itself is really important, so that's why we decided to include that in the agenda. And of course, what are the challenges of using the technology? What are the risks or pitfalls in actually using this technology? So generative AI nowadays is pretty much everywhere. You can see it like in the conference now. You could see it in it's having its impact in molecule creation, like in drug discovery, and even games as well. You can actually see it also in creating content yeah, and of course you might hear that it might actually compete with other human beings, like in terms of replacing jobs or outperforming a few tasks. It's no surprise, but like I said, there is a lot of potential in this technology, and basically, if you like to know when it all started, it's basically like during the pandemic. If you like perform a search and see where when everybody was actually starting to talk about generative AI, that was actually back in 2022, and like during the pandemic periods, where everything skyrocketed, especially after the release of ChatGPT, which I'm pretty much most of you have actually used before, or maybe if you haven't used ChatGPT before, I really highly encourage you to test out these language models that are deployed and made available through websites. So speaking of which, ChatGPT was actually, like I said, launched like approximately back in November 2022. And it actually made a huge impact. If you follow the news back then, you would have heard that it actually outperformed a lot of the social platforms in terms of like the number of signups in a very short period of time. It actually back then it overtook Snapchat and Instagram and these other social media platforms of course by storm. And since basically what is it? It's basically a chat, sort of a chatbot. Like I said, it took everybody by storm, and it was built on top of the technology, which of course maybe some of you actually heard before, like in the conference, which is based on large language models. And the version that was actually released to the public, obviously it went through many iterations before, but the major one that was released that actually had a solid impact was actually version 3 point. And for the research community especially, it actually had a significant impact on how things were actually done and how basically interaction basically was done through the use of chatbots. So for the like I said, for researchers and academic faculty and other members as well, it shook the domain basically, like especially how we would typically do our jobs, and of course how would we assess students, for example. When it was released, we noticed that these models could actually learn from specific interactions. So the feedback or human feedback aspect actually played a significant role of how this tool was made popular and how it actually overtook a lot of platforms out there. And so that's basically the spark. And obviously with AI, it's always the race of supremacy. So the better the technology, obviously the better the adoption. And of course, the interest would be basically sparked. So the race, of course, to higher grounds was actually began because of this technology. And of course, now we would hear basically a lot of competing platforms, some cloud and others, and like Google Gemini as well. Um, because one obvious aspect is because when you perform an interaction or basically chat with these models, you would witness that the sort of results that you would conceive or digest are basically human-like. So you would actually feel like if you recall the Alan Turing or the so-called Turing test in artificial intelligence, one might actually argue and say, okay, so this is a technology that actually can pass the Turing test. So what's next? Obviously. So this sort of slide, you might have seen this before a lot in many of the presentations before. But again, just to reiterate, the big bubble or the big domain now that is shying away or moving away now completely, almost completely, like from itself is basically computer science. So computer science actually, AI is actually part of computer science in general. And now AI is much bigger now, so it has to be now separated from basically computer science studies on all of its subdomains. So the big domain or the major domain is basically AI, and of course what comes afterwards is machine learning, which is obviously a branch of artificial intelligence that actually focuses on the creation of intelligent or so-called intelligent mechanisms or software applications that would actually rely on data sets of different sizes, especially large ones. It's another way of saying you would implement a software system that would actually perform a specific optimization while relying on certain data. And of course, the field that made generative AI possible, which is deep learning, and that is another subfield of artificial intelligence or AI, which focuses on the creation or usage of a special type of algorithm, which is called an artificial neural network, or neural networks just for short. And there are many examples of these deep learning models that were made popular, and they're still used until now. Even like in academia, we're still teaching those models, and of course, their variations. And there are many applications that still can rely on classical deep learning algorithms. But of course, with generative AI now, which is obviously a subfield of deep learning, we would see that they would actually be sort of more attractive in terms of practicality. And of course, a lot of people in organizations and people would strive for creating new startups and new opportunities, especially by relying on generative AIs. Again, the key difference between, let's say, deep learning and generative AI is, of course, from the term generative, where basically the model itself is capable of generating text, and not just obviously text, obviously multimedia, from imagery, from video, and other types of media as well. So that's how it nowadays obviously it became so popular and so like demanding now. So you basically see it almost everywhere. And of course, like I said, it's there are many, many types of models and examples that can be classified or listed under this sort of domain. So again, like I said before, it's a subset of a class of models that basically would end up, for example, experimenting or developing yourself or using in your organization, or if you're interested, like in research. Again, that you're basically taking these models that actually been trained on, and then as our colleagues before in the previous sessions also mentioned, they require large amounts of data, of course. And although the key difference between generative AI and typical deep learning models is that, of course, the data itself is humongous, if you would allow me to say that. It's basically a lot of data is required to train these generative models. And that's how we came into seeing large language models and or LLMs for short, and other types of models that are generally listed under generative AI. So the difference from other classical approaches, like I will give you examples, like in the slides. The slide that you see right now in front of you is basically, there are so many classical still being used right now in research algorithms, like random forest, decision trees, or logistic regression, and of course in deep learning, the most popular convolutional neural network and its variations, and recursive neural networks, and so forth. So these are classical or non-generative models. On the other hand, when it comes to algorithms or models that actually rely on data generation, that actually rely on a lot of data, you look at basically large language models and their types and their variations. And one popular example that also became so famous is, of course, diffusion models, where an example is called UNets. And it sparked the interest in creating applications that would perform something like stable diffusions and others. And another area which is also made a popular or a type of algorithm, which is called a GAN, or a generative adversarial network, where you have two types of networks connected to each other, whereby, let's say, for example, you would input a specific image or images, and then using a generator, you can either generate that image, or basically would try to analyze and see and test that if the model itself can either like identify using a discriminator, the second part of the network. And of course, if you're always interested, there are always there are available websites and tutorials that will explain these sort of networks. So these are just basically some of the examples, not every examples, because of course on a daily basis you would witness there are a lot of innovations and a lot of new discoveries in the area, a lot of cutting edge models, generative models that are making paving the way for newer discoveries. So in terms of the history, you might have heard a few key points that are pretty much interesting and relevant to the talk right now. And of course, how did we actually get here? And I guess as a revision, AI itself is not new. Again, it began like on paper, basically, with the basically like for over 50 years ago. It was made popular, of course, as you can see. It began on theory. And there were two AI winters where the interest actually fell down, or basically faded away significantly because of a few events. So and now, obviously, if I ask you, is it still growing? Obviously, yes, with the thanks to the new innovations now in the field, of course. So now, if you ask anybody, what is the next big thing? Obviously, the obvious word will come is basically generative AI, or someone would say large language models, and their applications now in many domains. And speaking of which, what was like one example would be how AI actually came to be was the event where the coining of the term AI actually came to be. So how significant was that? So at the Dartmouth conference, where the term is actually AI, or artificial intelligence, was actually first officially announced and used, John McCarthy is, of course, obviously one of the conference organizers, is actually given credit for coining and making the term known to society. And this event, this conference actually, is often considered as the founding moment, like I said, for AI, and obviously study. And this is how it actually came to be. And it was the first time researchers and fellow peers obviously developed the interest in AI, and of course it's sub fields like machine learning and so forth. So like in how machine intelligence can basically can be developed. So speaking of the conference, I'll have to always obviously give credit to the founders of this domain, from John McCarthy, who is known to develop the Lisp programming language. If you heard about this programming language before, which is still now taught in universities, like for example, the foundations of AI. How can basically students learn about AI, and how can they represent AI principles and techniques using computer systems? Obviously, one obvious option would be the Lisp programming language. Now it's kind of overshadowed by Python, of course, which is now it's like the language of choice for developing AI applications, and obviously generative AI and deep learning and other areas. There was also Marvin Minsky, who basically a scientist and AI pioneer who would later he co-founded the MIT lab, MIT AI lab. And there is Claude Shannon, of course, who is also known as the father of the information theory, where he brought a deeper understanding of the communication and information processing to basically to the table. And Nathaniel, of course, was an IBM researcher who also contributed in the proposal that they that actually made a significant impact. Assuming that you haven't seen this topic before in the conference, so now's a chance to explain one of the building blocks, of course, that when we teach artificial intelligence and its foundations, of course, the first thing that comes into mind, obviously, academically, if you want to say, is the creation or the adoption, or basically the perceptron, or the so-called perceptron learning algorithm, and how it actually came to be. So it all began back in 1958. Where the perceptron was actually proposed by Rosenblatt, and it was later coined or termed the Rosenblatt perceptron. It was introduced by Frank Rosenblatt back in 1958, and which is obviously one of the earliest models or representations of how an artificial neuron. So in the previous slides, I mentioned that deep learning is a class of AI like applications or solutions or algorithms, if you may will, that rely on the construction of artificial neural networks. And of course, the simplest building block of that would help in the construction of neural networks is obviously the perceptron. And back then, at the early stages, it was introduced, and of course, it was made significant. However, it was like I said, it laid the ground for the development of further enhancements to the idea of how neural networks can be developed, and how it came to be. And of course, it was inspired by biology. And of course, now if you're interested in, or if you come from a medical background, there is neurology and neuroscience, where the biological neuron can be mimicked or simulated using a computer system. And that's how computer systems or applications can sort of mimic the human brain, or perform certain actions or tasks that would behave normally, or look in terms of similar to what the human brain would do to some extent, of course. So obviously, it was the first attempt, and obviously there are significant limitations to the creation of the perceptron. And of course, later on, there were many attempts to basically overcome this formation or version of this model later on. So there was this book by, again, Marvin and Seymour, and it was released back in 1969. It's all about perceptrons again, which actually gave a nice introduction to how the idea of computation theory. And the authors, obviously, they critically analyzed the capabilities and the limitations of the perceptron. And like I said, it is the artificial neural, the building block of how neurons can be simulated using the computer system. So this book, like I said, presented the critical analysis, and it had a significant impact in the AI community. which obviously led to the profound to the period that led to the first so-called AI winter, where actually after the release of the book, during that period, the interest actually went all the way down, and AI wasn't really the talk of the time back then. So that was one of the so-called AI winters, where um, back then it was like the interest went down, and then after some time it skyrocketed again. So people actually developed a solid interest again in how AI can be implemented and can be adopted in many domains. So again, just to explain what an AI winter is basically it refers to the period or time of reduced funding, for example, where a lot of organizations, governments, and entities actually lost interest, if you may will, in investing into research and development using AI theories and principles, and the activity of artificial intelligence research in institutions and so forth. During that time, of course, the enthusiasm waned and, of course, went down. And these are some of the factors. So, like I said, so many researchers shifted their focus as a consequence, shifted away and to other domains and other possibilities. And some subfields of AI afterwards were continuing to develop quietly. So only just a few people around the world actually dedicated their time to write the foundations of, let's say, machine learning and other domains, of course, and that also helped in the breakthroughs that we actually see today in AI and its subfields, especially now with generative AI that we see now. And of course, with expectations, with the pressure, obviously, you either reach the goals or the expectations, or basically you don't. So one of the things that actually happened after the winter is the creation of the back propagation algorithm that basically is one of the building blocks of the most important algorithms in deep learning. And this algorithm is actually used even now, like in the foundational examples of deep learning. It's basically used to train an artificial neural network or neural network. How? By efficiently computing the gradients of the loss functions within the network with respect to the network's weights. And the process of obviously allows the network to adjust the weights to minimize errors, thereby improving its performance. So in case if you haven't really heard about the perceptron, the backpropagation algorithm, there are many components that actually would form the basis of this algorithm. Obviously, now we would see a lot of publications, even until now, though people will argue, is it still existing? Like, is it really still important in deep learning? Obviously, to some extent it is, but obviously we're seeing a shift away from the algorithm and given the evidence that is provided in, as research. If you follow like social media and especially the fathers of, or the forefathers now of AI, like Professor Yan, there was an interesting post that he mentioned recently about how now backpropagation was actually not of interest basically now. And these are some of the important aspects about backpropagation. Obviously, if you're interested to know what is this algorithm and where does it fit in deep learning, there are, I want to call, beautiful and nice and very easy to follow visualizations that either can be found online. If you just basically perform a search and look up backpropagation and how it can be done and performed within the network, you can see a lot of YouTube videos about this. And if you basically understand this, it would basically understand how, for example, classification can be solved using, let's say, the classical deep learning models and let's say CNNs or convolutional neural networks. When it comes to, let's say, classifying images and identifying the identity of each image or, let's say, a multimedia sample. So after the establishment of the perceptron, the idea came to like in 1986, where the multi-layer perceptron, which actually now forms the the classical deep learning algorithm or classical architecture, where if you want somebody wants to build a neural network, where obviously the other term for an artificial neural network can be called a multi-layer perceptron, where you have multiple layers in the network, and these are basically interconnected with each other. And obviously, the objective of any typical neural network is to update the weights and enhance its performance, while developers would aim to reduce the loss using special functions, and obviously to another aim is to increase the accuracy, the performance of the network when it's basically trained on the data. So obviously, the foundations were basically established back in 1986, and this actually led to the creation and of course MLPs or multi-layer perceptrons, which are now synonymously called also deep learning models, or basically neural networks, um, uh, basically are termed right now. So again, you developers have the ability, or researchers have the ability, of course, to specify how many hidden layers that they want in, or basically the layers in the network. The more layers you have in the network, the more complex the network would be, and obviously it would require a lot of compute to basically like rely on. Obviously now, if you haven't heard before in the conference, the key technology for now for training these MLPs or multi-layer perceptrons, if somebody's interested in learning about this, is obviously the reliance on the GPU or graphics processing unit. And of course, NVIDIA leads the way now in terms of enabling researchers and developers in basically enabling them to experiment on different deep learning models, and obviously generative AI models now using GPUs. And the discovery, of course, of multi-layer perceptrons actually paved the way for the neural network and the deep learning and its popularity, obviously. And of course, many applications because of multi-layer perceptron, like for example, pattern recognition, was also made famous. Just also worth noting. Okay, I'll just skip that. Okay. And basically, there is another significant moment that was proposed by George, which is the universal function approximation theory. And obviously, just for the sake of time, I'll skip this part. And if you'd like to know more about it, there are many articles that discussing this theory and how significant it was in the AI domain, and how significant, obviously, it led to the establishment of the technology that we actually see today, and for the creation of deep learning applications, and obviously the generative AI later on. When I mentioned the first AI winter, there was back in the first period, the interest actually went all the way down. But what about the second winter, AI winter? That actually happened during this period where basically, again, a lot of pressure was made, and uh, the expert systems, for example, initially, where some expectations during that period were actually unmet, although even with the resources available, that led to, of course, to the interest being put down in the area, where people again didn't really bother with AI, and they focused elsewhere on other aspects, and of course the economic impact. So like in the late 1980s, also because of the recession, this actually led to like a lot of budget cuts, especially in AI R&D, or research and development. Obviously, this led to the shift away from to like more immediate technologies, whereby solutions or innovations had to be made using other means other than obviously AI principles and techniques and the technologies, and of course with limitations, of course, like with compute. Back then, obviously, it was deemed quite challenging to take any theories that were established back then and to put them into practice using the technologies available. And obviously, all these led to the reduced funding from governments and, of course, from entities and so forth. So these are some of the impacts. One of the interesting and very noteworthy examples that I always like to share with my students, and basically a model which is called AlexNet, which obviously paved the way for the computer vision applications. And obviously it demonstrated how GPUs could actually accelerate the training of applications, of the development of specific neural networks that could easily identify, like, for example, cats and dogs, and further applications, of course. So it did receive a lot of like momentum back then. It was actually groundbreaking back then, back in 2012. Why? Because it significantly showed a way where advances in AI could be demonstrated and replicated using, of course, relying on GPU power. So back then, GPUs were pretty good in terms of training the networks, and obviously the deploying later on. So basically, like I said before, the deep learning and of course generative AI really relies heavily on specific hardware, which of course is basically the graphics processing unit. And with the utilization of NVIDIA GPUs, obviously a network like AlexNet, and as you can see in the chart, the time that took to basically train such a model actually was much smaller compared to the competition back then. And like I said, AlexNet paved the way for more advanced computer vision models. And again, this is one noteworthy milestone in the domain, and this is just a figure from the publication, where how the proposal came to be, how AlexNet actually was formed. Of course, due to time limitations, I won't be able to explain the technical details, and obviously there is always a chance for anybody to basically look the information up and find some key terms. Obviously, what all this what about generative AI now? So we've talked about the history before. What about generative AI? Why is this now so popular? Obviously, the thing actually that kind of comes into mind is the paper that was proposed by Google, and that is the title of the paper was actually called "Attention is All You Need." Because of that paper, everything changed. It would see a lot of papers and a lot of work and innovations after that time frame were established because of this attempt. So it actually introduced the idea of attention and deep learning, and obviously paved the way for the creation of transformers. And transformers is one of the key terms that are now made popular. And now there are obviously different versions of the transformers, where where in the paper itself, it explained one typical version of AI, which is basically called BERT, and of course that paved the way for GPT like models. For solving traditional natural language processing and understanding challenges. When I say natural language processing, obviously this is one domain that is also part of AI that deals with language itself. And of course, with language, there are a lot of challenges in actually developing solutions that would interpret how language is spoken, and of course how basically language is formed. And with transformers, we saw a significant improvement in the area. So the next generation of models after this, of course, would have an impact in the and how generative AI is consumed nowadays. And of course, if you're interested, you can see the paper online. And I really highly encourage you to look up the source and look into the paper and see how transformers were basically introduced back then. And of course, with such a technology, there was always a risk. There are always chances that something might actually go wrong here or there. So I'll just briefly mention a few notable aspects, and that is trust. And obviously now, if you look into like various sources and social media, you would find a lot of aspects, a lot of incidents actually happen because of the reliance on AI, and especially nowadays, generative AI. And these are some of the aspects, but then most notably, of course, is jobs. So, for example, a lot of people asking. I'll give you an example, like in the medical field. Some people, like in the physicians or like medical experts, are actually asking whether if AI can really replace jobs, and if you're presented with this question, obviously some jobs might be at risk, and some jobs can be reinforced. Well, so it's a two-edged sword, basically. This technology can either it could actually replace a few jobs, or it could empower people to accomplish more and better within short periods of time. And of course, one of the challenges, of course, misinformation, because if you have used these models before, the chances of obtaining information that could be misleading is still there. It's still existing. No, nobody can deny that. And the other issue now, if you see certain events nowadays, you would see that they're like here or there, you would obviously hear that fake news or fake articles or articles that are basically generated using generative AI are making their way in on the internet. And of course, the question is, can you really trust these websites? Can you identify these sources? So these are some of the issues. And of course, when people can be always skeptic, especially if they haven't really used the technology before, and if they're aware of how generative AI can be destructive, and what sort of applications and what sort of outcomes that this technology can produce, obviously fear comes into mind. And of course, you would see society actually divided, where a lot of people would literally you could see a lot of groups where people would go with generative AI, especially like from decision makers. It would see a lot of interesting applications and opportunities. Honestly, if they played it right, if they found the opportunity in utilizing generative AI smartly, of course, the organization or the like university, for example, would actually benefit a lot from using the technology. And of course, on the other hand, because it's a fragmented issue, you'll see a lot of opponents to the technology, and there will always see resistance. So the question, of course, that I would end up talking about is, or I hope we would also look this up also within time, and that is what's going to happen to society. What is going to happen now, especially that generative AI is here to stay, and of course it's not going to go away anytime soon. And on a daily basis, we can hear a lot of significant changes, and there's a lot of impact in many domains in society, in life, basically, just because of this technology alone. And if you heard about deep fakes, like, for example, fake news or videos that actually appear, for example, there's one example where, like, for example, people actually really find it hard to spot a video or a post on social media, and they would basically question themselves: is this source reliable? Is it really real? Is that person actually in front of the camera? Is it who it is? And of course, because of Gen AI, deepfakes actually became so popular, and obviously it's a big issue now, and it's an interesting domain where, and there's always I'm fascinated by the innovations in the field and the like the recent publications in the area. And if you're interested, I highly encourage you to see what is new in the domain and how organizations and companies are actually utilizing the technology for the greater good. And yeah, so these are some notable uh, challenges or noteworthy items. And of course, when it comes to jobs, obviously it is still there. The risk is there. Where, for example, where you might actually see this impacting an organization. So if you belong into a team where you would feel that certain tasks can be automated, then Gen AI can be incorporated and can lead to job loss. And again, don't take my word for it. You might actually see this happening worldwide, either locally or internationally. So it might lead to the reduction of opportunities in the market. And of course, it has an impact on skills. And I'll give you an example where we actually see this on a weekly basis, where students, their way of communication has actually changed significantly. Where, for example, if they communicate with instructors using email and other means, I really noticed that the style of communication has actually changed significantly, where you would ultimately know that this person's way of, let's say, writing is completely different if you know the person or the student from like years ago. And obviously with Gen AI, you would obviously see a sort of a behavior where the student, for example, would attempt to, let's say, lose their trust in themselves and actually writing, for example, good English. And if they have certain ways and they want to, let's say, utilize Gen AI and basically establishing these communications with faculty or their teachers, you would see they would use the technology, and then you would realize that, wait, the students are actually relying a lot in their replies on Gen AI. So that's one example that is actually seen. So in terms of like skills development, obviously it's a significant thing, and like institutions have to pay attention to this. And notably, a lot of leading institutions have actually established mechanisms to combat these issues. And yeah, this is the one example. And on the other hand, you would actually hear that a lot of opportunities have opened up. And if you've heard the few of the topics before, there is the job of prompt engineering, where I was so surprised to hear that the salaries for this position, although it might be, if you haven't heard about prompt engineering, the concept might be simple at the beginning, but obviously it's not, where certain people have discovered ways of designing specialized prompts that would tell the model, like the large language model, to basically spit out a sort of answer that is kind of closer to a specific style or persona, if you may will. And this is one example of some of the jobs that were created that were otherwise weren't available before. And if you ask me one possible domain or skill set that might be kind of, I don't want to say replaced, but is challenged now with generative AI, and that is data science. So with the idea of automation, you might end up having a certain data science tasks automated using tools and technologies. And obviously, organizations might actually think twice about, for example, either hiring a person or data scientists in their domain in the workplace. And obviously, if not, they can replace the typical skill set with Gen AI tools. And obviously, there is always a big debate about this. So we talked about the history and the risks, and what, again, sort of a soft introduction to generative AI and its history. I hope I've explained at least the foundations of this important technology, as if you've attended the conference from the beginning, you've seen a lot of inspiring talks about this topic. I would like to give the floor to all of you to either ask questions about what was talked about or discussed in the talk. And I thank the organizers for this amazing opportunity, and for allowing me to come and present this topic to you. So many thanks to all of you. And now the floor is given back to you to basically ask any questions. Feel free to ask any questions in the chat. And yeah, many thanks.